Hi Lionel, welcome to our MOOC on software testing. For the viewers who don't know you, can you say a few words about yourself? Where do you work? What do you work on?
Yes, I'm working for a center focusing on security, reliability, and trust, which is part of the University of Luxembourg. I have been doing research on software engineering and software testing in particular for the last 25 years, roughly. And I've worked in 6 countries, including the US, Canada, Norway, Germany, and others. And I've worked for about 30, or I've worked with 30 to 40 companies in my research projects in various domains, automotive, aerospace, banking.
Wonderful. One of your areas of expertise is model-based testing.
Yes.
Tell me, what is model-based testing?
Well, in testing, one very important aspect is to be able to automate the testing process. That is, automate the generation of test cases, the generation of test verdicts, that is, the mechanisms to automatically detect failures, and of course the automation of the test execution itself. And to enable that degree of automation, you need information about the system, the expected system behavior, some aspect of the system architecture. That's a necessity to automate testing. And when we talk about model-based testing, that's what we mean. We mean test automation that is driven by some representation of the system behavior and/or architecture.
Okay. And can you maybe give an example of a successful project in which you applied model-based testing?
Well, I have applied some form of model testing, that is some form of test automation in many different domains. But one recent example that has been quite successful is in the area of advanced driving assistance systems. You know, those systems that are increasingly popular on cars, such as preventing collision with pedestrians, intelligent cruise control systems, emergency braking systems, stuff like that. And it's a domain where model-based testing was a very convenient thing to do, because in that domain, people build executable models of their physical environment, of the hardware, and of the main control and decision algorithms. Okay, so very early on, you can actually do automated testing.
I see. And what sort of models do you typically use in this model-based testing?
It varies quite a bit, because the practices, for example, the modeling practices and the development practices from one domain to the other vary a great deal. And what you want to do when you do test automation is that you want your test technology and your test process to be fully integrated in a seamless manner with the rest of the development process. So you have to adjust to that. What type of models is, they could come in many different forms. Of course, one obvious form would be some form of UML analysis model that is developed in a certain way using what people call profiles, that is specializations of UML or extension of UML, to make the models test ready and to enable test automation. But you know, I gave you just before an example where we were using Simulink models, because that's what people were building in the early stages of developing those automotive systems. So it varies quite a bit from context to context.
And a very popular testing technique is, of course, unit testing. If I do very good unit testing, why would I still need model-based testing?
Yes. Unit testing is not really a methodology. It just says what is the scope of testing. So you're testing small units. Usually unit testing is performed by the developers of those units themselves. The scale is small. So very often when you discuss with industry, their most acute pain point is not testing in the small, it's not unit testing, it's testing in the large. System testing, integration testing, acceptance testing. That's where it starts becoming a problem, because first, the people performing testing are not the ones who develop the software under test. And second, the scale makes any form of manual testing very difficult, even though that's unfortunately a common practice. And I don't also know what really proper unit testing means. But of course, you
That's
can.
a very good question.
Yeah, of course, you can apply also model testing to unit testing, but I don't think that's where the main benefits are.
I see.
Again, because the people performing unit testing are the ones who developed the software under test, so they have that domain knowledge and and design knowledge. Yeah. So.
And now, if I would want to start in my projects playing with or experimenting with model-based testing, what would a good first step be? Which models or tools can I use?
Well, there are commercial tools that exist. I mean, there are a number of companies who provide, I don't want to do an advertising here, but it's easy to find by Googling.
We will.
But there are a number of companies that provide model testing tools. Usually, the problem with those tools is that they tend not to be very flexible. That is, they are not very adaptable to your development process and your practices.
I see.
So that's the opposite. They force you to kind of adapt your development practices to what they require. Yeah. And that's often the problem with those tools, but still.
Maybe that connects to the next question.
Yes.
What are common pitfalls to avoid when trying to apply model-based testing? Things that can go wrong?
I think for practitioners is to adopt a model testing or test automation strategy that is completely disconnected and not integrated in their development practices. So ideally, when you do model testing, you want to reuse analysis models that are used for other reasons, that are used to specify requirements, for enabling traceability, whatever is needed in the domain you are working in. And you want to a large extent reuse the information you produce for other reasons to enable automated testing.
So if the models are only used for testing, that is a risk.
Well, there is a risk, or at least the benefits will be more limited.
I see. Yeah.
So you don't want people to have to build models of the specification of their requirements only for testing purposes.
I see. Yeah. Yeah.
So.
Maybe a look at the future. What is the future of model-based testing? Is model-based testing here to stay?
I think so, because in most contexts, there is no real alternative to make software testing fully automated and testable. For example, if you look at a lot of the work done in academia, there is often an underlying assumption that test execution is free. You can run a lot of test cases and it has no real consequence. In most domains, especially when you do system testing, integration testing, and acceptance testing, that's not the case. So you cannot guide test execution purely by results from test executions, from previous test executions.
Yeah.
So you need another source of information to guide testing, because the idea when in such contexts where test execution is expensive is that you want to achieve the highest possible level of confidence in terms of the dependability of your system, the reliability, security, and safety of your system, by minimizing the amount of testing you perform, or at least by keeping it within a certain budget and timeline. And therefore, you need some kind of information about the system to guide that test automation. And it cannot be test execution itself. It cannot be some large number of randomized test execution.
You need the models and those guided tests.
Yes.
Lionel, thank you very, very much.
Thank you.